All right. So back to where we started at the other day, we can look at all these text items. So looking at chapter 4, I'm looking at page 95 to go quickly over the length function again. So the length function tells us how long a string is or how long an item is. And so that's very, very handy. We can tell how many characters, and remember though it counts all the spaces. So when I look at that, the other thing we have to remember is it counts from 0, and we normally count with 1. So we're getting to the point where we can look at strings and be able to access individual slices and pieces of them. One of the really handy things, and this is very, very slick compared to almost any other programming language, is the ability to ask if a character or something is in that list. So if I look on the middle of page 95, where it says if E is in a message, no other language that I know of right off the top of my head makes it that easy to manipulate strings and characters. So it's pretty slick. So I'm going to look at, if I can get to my folder here. So this message analyzer, we're going to open it with idle. So I've got another window here. So this particular program has this message. So the message is equal to enter a message. Okay, so whatever we type in, we now get the length of it. It asks, is E in the message? So we could change that to any letter. So I'm going to run this really quickly. Enter a message. The quick brown fox something something something. So length of your message is 19 characters. The most common letter in the language is E, and it is in your language. So we could rewrite that again. So it's just a quick way to show you how quickly we can look at these kinds of things. So if we know then how we can create how long it is, one of the other things we can do is access any particular piece of that string. And that's going to get kind of important when we start looking at how Python works with these ideas of strings and functions. So if I want to print out an individual message, so I want to print or int chunk backwards. All right, so I want to print, and I want to print that message. So I know it's going to be a function. Print's always a function, and I want to print message, whatever it is we typed, but I want to print only the first letter. Well, notice those square brackets. I can grab that first letter by that position. Now, it's a little dangerous in this example because I don't know how many characters they're going to put in. But I'm pretty safe with that first character. And remember, it's character 0. So I could actually run this then. What did I do there? Okay. What did I do? Oh, sorry. I knocked out the... Sometimes if you have an error, the other thing I'll give you really quickly as a hint is if I have an error in this line, look above it to make sure you didn't do something silly like forget a ending parenthesis. So my message is 5 letters long. Here I get that it does have an E, and now I printed out just that first letter. And so that gives me some tools to slice up, and I can do that with positive values. So in this particular case, I don't know how long it is, and I'd have to build in some error checking to make sure that I don't go past where I think it is. But I can access those just about anywhere. I can also use, and you'll see on page 98, I can use negative words or negative links. And negatives take from the right side. So if I want to go all the way to the right side of this message, I can do that also. So I can use positives and negatives to grab anything that I'd like in there. So I can use these same techniques then. Oop, darn it, go. And I can look at creating a random index. So here's a word. So we're going to put in a value. So we're just calling it index. We could change that to anything. So let's change it to Peru State College. So we do a couple of things here. So we're first going to just print out what it is so that everybody knows what we're looking at. And then we set a couple of variables. And we set the first variable as high, and that's the length of the word. And then we set it low, which we set as the negative of that word. Okay. So just to show you what those are going to look like, it's sometimes as a test we can do this. We could say print high print low. So we're going to add a little to this program just so we see what those values are. And then here we set up a for loop. So for I in the range of 10, okay, position equals, so we're adding in a random between the low and the high values. So does that make sense? We're creating a random number. And now we're going to print that word and an individual position. So let's run this and I'll show you what it looks like. Yes, we're going to save it. Okay. So the word is Peru State College. So we know that we have 18 characters. Well, and the negative of that is minus 18. That makes sense. And so this just scrambles those from place to place. So we did 10 random characters out of there. So what we're doing is setting up for the ability to create things like a word scramble or something like that. So these are all letters we took out of this string. So that string is right here. And so now we just printed whichever one is in this position. So all this does is show where we're at. And then we printed the word, whatever letter happens to fall in there. So that's just one strange thing we can do with this. But the idea is, and if I look on the top of page 99, there's a very quick little chart, that figure 4-6. That kind of shows you what we're looking at. Every piece is a box. Every piece of text in here is its individual box. So P is in one box, E is in one, R is in one, and they're all labeled. And they're labeled, if we look from left to right, from 0 to 4. But if I look from on the negative side, it's labeled -1 through -5. So that's a little confusing, but once you look at it and you say, okay, that makes sense once I look at it. So it looks like we can just manipulate this text at will then. And I did show you that we can move things out of there, but one of the things that we have to work on is something called immutability. The immutability. So, page 100. Well, we can pull things out of that string. I can't change that string one character at a time, though. That would be kind of nice if I could do that. So, if I could change that value in word, and I could change it, that would make life a little easier. But the reality is I can't change it unless I assign an entirely new value to that string. So if we look on page 100, they talk about this idea of immutability. So Does that mean that we can't do anything with it? We can create a new string, though, on the fly. And so there's an example of that in our text. And it's one of these, I encourage you, you really, really, really have to go through. And so this one is called the No Vowels program. And again, you need to go through and build this on your own and look at it and see if you could come up with why it works. So in this particular case, we're going to put in a message. So we get to type in anything we want, and that becomes message. We also are going to use a variable called new message, and just with good programming practice, we set it to a null character, so there's nothing in there. And then we get a list of our vowels, A, E, I, and U. And what we're doing here then is we create a for loop. And that for loop runs as many times as there are letters in message. And so we have a variable letter, and so that's going to go from 0 to however many characters we have. And that for loop, we could do the same thing with the while loop because we have that length function, but this is just a shortcut for us. And so now we're going to look at another function in here. So if letter.lower is not in vowels, then we're going to add it to new message. And so that's all that does. So this if statement says if letter.lower. So we could also do .upper, we could do, but we're breaking it one by one. So not in vowels. We're going to add it to our new message, so we're creating a new string. So let's run this. And so if I type in my name, for example, I run that. And now this happens to just print every time, but there's no reason we need to print it every time. It just shows you that it grabs each line, each word, one at a time. And notice it strips out those variables. And we could do the same thing. We could edit this, and we could manipulate that to add the B in there. So I could add B in there as another letter. Run module, okay. And notice now it strips out the B also. So all we're doing is just manipulating that text string one letter at a time, just like we've done before. And now we're putting it into a new message if it meets the criteria. So that's one way. If I think about the hangman games, we can look at it and manipulate our text that way. So that new vowels program that starts on 100 and 101. So there is something we did a little different though in here. And notice we capitalized that. Everything else we've always done is lowercase. Well, we do that just to show that we think it's a constant. In other words, it's not going to change in our program anywhere. Most programming languages use constants that really are constants. Python is so flexible that we can even change the constants. So it's really a naming convention for us. So when I look through that program, I can say, oh, okay, that really is a constant. I shouldn't change that. So 103, they talk about how we create that new string. Well, that's pretty handy. We can grab one element out of a string at a time. We also have the ability to do what's called a slice. So a slice means not just one letter at a time. We can take an entire section at a time. So if I look on page 107, so it's very similar. We just printed word. Well, now in those square brackets, not just a single position, but we have two positions. and it's going to take every piece of text between those two positions and return it to us. So we can grab an entire slice. Now, we have to be careful with any of these slices, or if we're grabbing individual elements, to make sure that that slice really is in where we'd like it to be. So, why are we talking about all these weird things? Well, remember we did those arrays back in our pseudocode where we could put groups of elements in arrays. Well, we're going to look at something like that in Python, but Python has a special name. We're going to call it a tuple. And you probably haven't heard the word tuple, so it's on the bottom of page 108. And a tuple allows us a whole sequence of things at one time. And Python's so flexible that we can literally create a group of these things that are both numbers and strings, text strings, all at the same time. So I could create a variable, and I could say names, and I could set it equal to something. And I could set it equal to, and notice I hit a comma, and now I put in another name, and I can do this. And so that's interesting because now I get so let's see what happens when we do that. So we put 3 pieces in there. So let's run. Yes. All right. And notice it prints out all the items in my list. So it gives us a way to store multiple items, and we can look at them by positions. And so we're going to be able to look at how do we start breaking those apart, because it gives us a pretty quick tool. So Python is more powerful in that it doesn't care how many things we create in there. It also is oddly different in that it doesn't care. So if we use other languages, I would have had to create an array, and even manipulating these items afterwards becomes kind of an interesting problem. So if I look at, I'm going to bring up another program here. So again, we're going to just quickly look at one for speed and efficiency here. So same type of example. We're going to create an empty tuple. So in other words, inventory equals, and that's just good programming again. We're making sure it's empty. We're going to make sure it's not empty. So the first question is, you are empty-handed, and it just makes you enter the enter key. So that's just verifying that it is empty. And then we put inventory. So inventory equals sword, armor, shield, healing potion. And notice we can put those on separate lines just to make life easier for us. And so now we're going to print that entire inventory. So we printed that entire variable. And then we're going to create a for loop and print each item individually. So for item in inventory, print item. And that's all we have to do. So in other words, it loops through as many times as we have items in our inventory. So let's run this really quickly. So you're empty-handed. Yep, no kidding. So the inventory is sword, armor, shield, healing potion. And then here we list them individually one at a time with that for loop. So we could list as many items as we wanted in there. So maybe we wanted to put 13 in there. So let's see what happens. And notice I put 13 in there as a number, and it gave me 13 back out very, very quickly. So we can look at this and we can do some interesting processes. Yes, I want to kill it. So now we have all these things in inventory. We could also look at, what does that length function do then? So the length of, so notice we have a function inside of a function, which is kind of inventory. So make sure when I do that I match up those parentheses. So now I'm going to run it again. Now, I didn't make it pretty, but notice here that length doesn't tell me now how many characters are in the entire string. It tells me how many items are in that string. So if I didn't remember how to do a for loop, I could create a while loop because I could do that inventory, I could do that length. And that length tells me how many pieces there are in that tuple. So if I can do that length, I can probably do that same type of index then. And so I could print out individual pieces. Again, though, one of the strange issues, I can't change that. So if I need to edit this on the fly, I have to assign it to a new value or a new variable and then change it back. So tuples can't be changed on the fly, but again, we can assign it to a new variable and then you manipulate it that way. The only time that really becomes a problem, and where this would be handy, is think if I had a tuple that had 1,000,000 elements in it. How long that's going to take to copy, change, and then re-put back. So what I suspect is in version 4 of that there will be some method to to manipulate these a little more even. Because that's what we seem to find is we add more and more things and try to make this as easy as possible. So on the bottom of page 115, there's a term called concatenate. So we join them together. So we can use a plus symbol to put things together. So there's an example of that on the bottom of the page that flips over to the next. So we could add two items together. So if I had two strings, I can use that ability to just add them together. And that's kind of a handy thing. So I can't directly change them, but I can merge two of them together into a new string. So let's look at this word puzzle game. So there's a puzzle game in here. I have about 4 billion things too many open here. But if I look now, there's a word jumble. And make sure you look at all of these programs, work through them. So this is a word jumble program. We've all seen those in the newspapers or something where it takes a word, jumbles it up. Well, we're going to look at this and say, okay, let's see if we can do that. So the first thing we're going to do is we know we're going to import that random function because we're going to use a random feature. And we've created a series of words. And so the words we created, we used Python, jumble, easy, difficult, xylophone. You could create a list of as many as you wanted. And so we're going to then pick one randomly. And this is where Python is pretty slick. So in other languages, I'd have to find out how many items are in the array, find a variable, and pull it out individually. Here I can just say, well, random.choice out of words. How cool is that? So if you've worked with any other language, that is amazing. That's 10 to 12 steps that you just did automatically. Done. Okay, so the next thing we're going to do is we're going to assign that to a variable called correct. So whatever we pulled out of here becomes correct. We're going to make jumble blank. And then we scramble it here. So position equals random range, the length of the word. So whatever position we're going to look at, we're looking at how long that word is. Jumble equals that word position. So one at a time it's going to add them to jumble. All right, so this is the piece that scrambles the word inside there. So if I added a print in there, it would print that scrambled word right here. So this key, it's each position, and then the next position. So notice, see, it says position plus 1. All right, so it uses that plus to concatenate them together. So that puts that string back together as word. We're then just doing some print to make it interesting, tells us what we're doing. And then we have to put in a guess. Well, the same type of thing here. So we used a while loop. So while guess is not correct, so it's not equal to that value of correct, and guess is not equal to a blank. So if somebody puts in a blank, we don't want it to trigger that. Print, sorry, that's not it. So if they enter a blank, it forces them out of the game, and I'll show you that here in a second. So and then we have an if down here. So here they just looped back and forth, so it'll let them guess as many times as they need to. Here we have an if guess equals correct, and you get the you win. So let's run this and see what it looks like. So welcome to the game. The jumble is YSEA. So I'm going to put in 1, 2, 3, 4. Nope, that's not it. So anything I do, it just keeps looping around. So if I type easy, if I don't hit the highlight key there, I type easy, wow, I guessed it. And I won. Well, let's run this again, and let's see what happens if. So my guess is, I don't know what, I don't even have any clue. I'm going to hit enter. And it says thanks for playing because I didn't win, and it accepted a blank entry and let me get out of there. So this program, really, the honest reality is, written in almost any other language, would be significantly harder. We would have to go through and assign values and variables, and we would have to create a length, so how many characters there are, and we would have to do all these things manually that literally we do very, very easy there. So looking through the chapter, look at page 118, and it shows you again, it'll tell you also about how we created that word version. In other words, how did we scramble that? We can change these, so if we wanted to put in there, notice we didn't have to set up a specific length. We can add to this on the fly. Oh, and of course it's not going to generate that one for me. It'd be nice. See if I can get it to. Now, that one's actually kind of easy. Notice what it did there. That is legitimately a random value, but it actually reassembled easy. Interesting. So, I was hoping it would bring up our newest one. No, it's not going to cooperate. But that's all of the items that you've already learned and dealt with. So our assignment this week we're going to improve that word jumble file. So you need to be able to manipulate that. So now you're going to have to see if we can come up with a way to pair each word with a hint. So, a couple of things we have to add. So we've already got our module, so the word game works. How can I create something that's going to make a pair with a hint? So what might I be able to do? Because I've got that list of items in there. So we need to think about a couple things. We're going to pair it with a hint. Then how do we get input to see if they need a hint? And then we also need to add a scoring system that rewards those players who solve a jumble without asking for a hint. Okay. So we're going to pair each word with a hint. So let's think about that first. So my first idea, oh, I spelled for at the Young College. Interesting. So remember how we worked with in pseudocode those parallel arrays? Could we create a parallel tuple so that we could reference whatever position that is? So in other words, if I know which position I'm pulling here, so if I pull position 4, that I could pull position 4 in a parallel array. Is that possible? Well, let's just try something and see what works. So I have a value here called words. So let's just try seeing what happens. So I'm going to create a second set of variables called hints. And so snake maybe for Python. Maybe scrambled. Opposite. So I create my list of hints that I'm going to give to them. Bell thingy. Where you study. All right, so I created essentially a parallel array. So I know that if I print what am I going to get? Okay. So we hope. So if that works for that, what happens if I print now? Let's just save that really quickly. Save. All right. Now notice I misspelled scramble. Okay, so wait a minute. What happened? Oh, because we start with 0, remember? All right, so My spelling's not good. I notice I can't spell on the fly here. So I have those parallel arrays. So I could print those. Okay. So how can I access that array? What can I do? So here's where we pick a word out of our list. Here's where we assigned it to that value. So I'm trying to think of what can I do, because we just grabbed that value out of there. How do I know what position it is at this point? Well, that's interesting. How do I assign it? So we can make that parallel array. That could be our hint file. And we could probably come up with a way to ask a question pretty easily. So we could say, if guess, sorry, that's not it. So the first time they're probably not going to need a hint. But we could create inside of here, perhaps, that function of asking for a hint. So in other words, we could create print type hint if you need a hint. And then we could put in an so now we're going to look for a couple of things. So we have type hint, so we've got a guess. And then we could put in if guess equals, remember we got to do the two equals. If guess equals hint, then we have a set of things we could do here. So if guess equals hint, then print. How are we going to get to that hint function? So there is an issue. How do we find? So we know we want hint of something. But how do we find that value in that tuple? So that's the part that's going to cause you some consternation. How do I figure out how to get to that particular hint piece? So we have these up here. And in every other language, we'd have an index variable we'd have had to create to get to that. So we'd have picked a random number out of however long that length is, and we'd have had that available. But Python is almost too helpful in this case because we picked a random choice out of words, but now we have to go back and figure out what position it is inside of that tuple so we can pair it with another variable. Oh. Well, Well, there's a lot of different ways to do it. But logically, what makes the most sense to be able to do that? Or is there a better way to create our list of words? So one option that comes to mind is is there an easy way to pick just every other word? So in other words, if I had that random list of words, and my hint and my original word were side by side. So instead of a separate list, it was Python, comma, snake, comma, jumbled, comma, scrambled. And I could somehow grab a variable word I could just do position plus 1, if that's a possibility. I could create a while loop up here. So we know, or after we pick it, honestly, sorry, so that it looks at and matches those up. So in other words, we create a for loop for the length of that tuple, and it compares correct to back to the original tuple to obtain that position. That would be one way I could do it. There might be some more elegant ways to do that.
There's no way we can access what, like, random number it chose, then?
Not that I know of, unless you come up with something.
We can't take, before we ever do anything with the random thing, we can't use it.
Okay. From other languages, it might be easier if we did a length statement of our tuple. So we could do that. So we could say, and I'm just going to, this is by no means syntax correct, so this is just an example. We could take the length of words, and that gives us a value. Then we could do a variable. So we could do a random of that length to pick our variable. And then we assign whatever word is equal to not random.choice, but the position that we're going to pick. So we do a random value. So in other words, if the length of the words where we had 9 words in there, and we don't, we would then get a random between 1, well, actually 0 and 9. Because it's 9 long, so it's counted 0 through 8. And then we would assign that, pick the word value that way. It would also give us our hint value very quickly. So we could change the program fundamentally. Or we could, like I said, do a while loop to search through the tuple and find its position and then match it that way. So there's really a lot of different ways we could do that. It just depends on which one seems to be most logical for you. Maybe there's some other ways. So maybe we go to python.org. And we look at what does random do. Maybe we look at the back of the textbook. And if you look at the back of the textbook, there's some items also. There's links to references, and see if that happens to be in there. There's animation, there's keyboard, there's classes. So the games function. So there's already some existing things. But maybe we want to just type in random.choice and see what it returns to us. Ah, interesting. So let's look up random. Okay. So there's a lot of different information in here. So this talks about all different kinds of things. So maybe what we need to do is go to documentation. And we want the 3x documentation, obviously. And from there, we'll type in random. And notice the search engine works a lot better. So we can look at what we have in here. Generate random numbers. And we can click on python.random.choice. Return a random element from a non-empty sequence. If sequence is empty, raises index error. So when I look at this, and there's all these different functions, and so notice there's a ton of different random ones that we can get. It doesn't look like there's an easy way to pull that out. So, if you shuffle them equally. Okay. Oh, okay. So in other words, correct. Well, and what that is the same as what I mentioned here. Instead of just using random.choice, because obviously that's a quick way to just do this game, but if we want to add that feature, what you're saying is very similar to we find the length, so length of words, and then we get a random variable. And then we pull a word from words at that index. In other words, so if we had this and we got the random 3, so it would be 0, 1, 2, 3, it would be difficult, is what we were pulling out of there. And then we could also pull a word from hints at the same index. So that might be the quickest way to rewrite that program a little bit to do that, rather than search back through and try to find that index point. Now, I love how your ability very quickly with random.choice is that we can pull a variable out. But in this particular case, if we look at it in terms of a parallel array, so in other words, to get those hint functions, maybe that's not the easiest way to do it in that particular case. So we may have to rewrite a little bit of our code.
If those were strings in an array, would the length of words still be?
Yeah, length always, when we ask it of a tuple or an array, if you want to think about it that way, it returns the number of elements in that array. Now, we can get the size of each individual element with that length statement also, but we'd have to address each one individually. But length in itself gives us just how many elements there are in that array. So that would probably be the easiest way, quite honestly, to rewrite that, is to modify it that way. And so part of the reason I picked this as an assignment is it gives us that ability to start looking at existing code and trying to figure out how we can modify it for our own purpose. The reality is we could even then, if we created it in that manner, we could create a hints to parallel array. So you could have a set of 6 different hints if you really wanted to get complicated. And so each time they hit enter, and they couldn't get it, you'd give them a different hint until those hints were exhausted, and you could come up with an exit strategy for that. And you could give them more points based on the number of hints they didn't use. In this particular case, we're just asking for giving them a hint and giving them a bonus point or something. So a very easy if statement down in the bottom, would work very well. If you come up with some way to increment a counter if they do get that hints function, and then they just get no points or whatever. But the hardest part on this problem, honestly, is how do we find out that index point? Now, the other thing in terms of maintenance, this requires us to make sure that if I have X number of items in here, that I have X number of items in my hints file, and that they match up. So there might be some other interesting ways to do this. In terms of making one giant tuple, taking an index of it, and using that paired method that way. But there's literally 100 different ways to do that. It'll be interesting to see how you come up with that solution. How do we arrive at all the tools are available for you? And certainly if there's something you don't know or you don't quite get, I want you to make sure you look at those helpful hints sections, look at those resources we created on the discussion board. Go to python.org. Now, python.org, honestly, you need to go to the documentations, and I tried to make that, just show you that a little bit there, because the main search doesn't always do what we want it to do. So you need to go to the documentation for .3. whatever version of Python, look at it, and go, oh, look at all these options for random. I could do a random X variate or something if I were in, wanting to deal with statistics. So if I look here, there's all different kinds of items. So random.shuffle, there's random.random, random gamma variate. Some of them I don't have a clue what this would be. So a Weibull distribution, if you wanted to, whatever that is. So there's some of those we're obviously probably not going to use. But the random range is pretty handy. And that random integers is probably the most common thing we're going to use. So there is an assignment in the discussion board to make sure that you work on that. So this particular week, we look at, now that you're getting to be accomplished, oh, I hate when it does that now. It used to, when you click on it, it would actually show you this piece also. But we're looking at a couple of different sites. And if you find a different one, so there's all kinds of challenge sites and things out there. Now, are some of them far beyond what we're going to get to in the next 8 weeks? Yes. But it's interesting to see what you can do with Python and where it's being used at. So be sure you look at that and go look at some of those. Some of them, like the last one, and I made you read through all of them, like the coding bat, has some additional pieces mostly for beginners. Whereas if you look at the Rosetta code, it's pretty hard in terms of what they're looking for. So this one, for example, yes, I want to show content. Go. See if it'll open up inside there. Yep, it's not going to. Handy. You may have to open those inside an exterior window or copy and paste, so depending on the security settings on there. So we'll post this video up.